All right. So here we go again. Remember, the whole point of this is I am working on my presentation that I have to give in a couple of weeks. So I'm trying to make sure I work through all of the kinks. In this case right now, I'm just trying to, get through it once in some respects. I mean, I have tested all the different parts of this before, but now it's kind of, trying to bring all these different parts together. So let's go to DevOps Elvis and to my GitHub Actions presentation. Repository. Let's see, I think when I left off, I'd pushed the code, I'd created a PR. I had created the rule set, the repository rule set. Which made this check required. And it passed, which then allows me to say, oh, I wonder what that check's all about. Let's go look and see. So it looks like it ran a GitHub Actions workflow, did a build test and create deployment files, and then did a post. And if I go to my summary page, then we can see that here are the files that I could potentially deploy if I wanted to deploy them. And it looks like all of my tests pass, including the one that was failing earlier. Well, that's great. I wonder what's actually going on here. Well, we can actually see the workflow file that was used to run this check. And this is a workflow file. You can see it's in my .github/workflows/haiku PR composite action build test YAML. And if we look at this workflow file, we can either trigger it manually, or we're triggering on the main branch whenever there's a change in the haiku source folder. And then here is the job that we saw was related to making it required. Build and test on PR, running on Ubuntu latest. And right now this job only has one step. Oh, that's the other thing I need to do. Let's go put that on the to-do list. Add steps to workflows to trigger the build light. So the lamp that I have behind me there is actually it's got a smart bulb in it. So I can during the build process, I change the color, and after the build, whether it's successful or failure, I change the color appropriately. So I've added that to my list of things to do. But if we look at what this one step is doing, it is doing a build, test, and create the deployment files. Now, I'm not checking out code. I'm not doing anything in this workflow file. I am simply using a custom action that I have built to do all of those things at one time. And the reason I'm doing all of those things at one time is because I found later on when I do the push to main, I'm doing those exact same steps in the push to main. So why not just put them all in one custom action and use them that way, which is what I'm doing. In this case, it's a composite action. So it's going to be in DevOps Elvis. It's in a different repository, and I'm targeting the main branch for the version right now. So let's go see what that custom action would look like. So we'll put a github.com in front of that. And here we go. So the idea is at this point, I can see we're using a custom action. So I can come over here. I can show you the action.yaml. I can explain. We give it a name, give it a description. We're expecting an input, which is where the source files are. Using composites, the secret sauce. And then here is where we are doing things like checking out the code. We are doing an npm CI to, pull down all the dependencies. We are doing an npm test to run our tests. we are doing and then we're creating that test summary that we saw, taking the outputs of the test and turning it into a markdown file that is always running. We are writing that test to the job summary, which is a special, I think it's a file. I actually think this is a file, but it could be an environment variable. I get confused. I have to go look at the docs. But we're writing the information there. That's what makes it display on the screen. Then I'm actually going to use Vercel to compile my code down into a single file, so I don't have a ton of packages and all that I have to deploy. I'm compiling it down to a single file. I found that this took my deploy time by using that file down from like 3 minutes to 10 seconds. It was insane. So then I need to copy the files that I'm going to use for deployment. Those are bad lines. I need to take those lines out. So let's make a note of that. In the custom or in the composite action, remove the commented outlines for copying the files for deployment. But I'm just copying all the files I need for deployment, and then I'm uploading them so that as a developer I could look at the files and verify that they look good or they don't look good. Okay, that's great. So that all seems to make sense on how that works. Let's see, explain how it works. Rule set, and oh, let's go see something. GitHub.com, GitHub changelog. Just want to check something out. Okay. Nope. Thought there was something there, but it's not. So that's okay. All right. So this worked. So we'll go back to our repository here, and since everything looks good, we're going to merge the pull request. So let's open up the pull request. Let's go down here. I like to do a squash merge just because that's how I like to do things. I'm going to confirm that squash merge. I'm not going to delete the branch. I could delete the branch, but I'm not going to. But what we will notice if we come back out here to the Actions tab now, nothing's going to happen. And the reason nothing's going to happen is because even though I remembered to enable the composite action workflow, I forgot to enable the push that uses the reusable workflow. So let's enable that. And since we've already pushed, what we'll do instead is just run that from the main branch. And so here's the workflow that's going to run on the push to the main branch. And it's got some more stuff going on, right? We're doing the build and test, but then we're deploying to a dev environment and a staging environment, and also to a prod environment. You can see the build and test all work successfully. And here we're deploying to dev and deploying to staging. So let's look at how that reusable workflow is actually working. So if we go to the workflow file, this is the workflow file that's getting called when we do the push to main. Push to main. Now this is required because by default you got read and write access. We need a little extra access because we're using OIDC to connect to Azure. We're deploying to Azure. May or may not show OIDC. Let me make a note of that. May or may not show Azure OIDC. But we can see that Oh, and I need to make sure that also add steps for build light to push as well. So we want to do the steps of the build light on the push as well. So here we've got the job that's doing the build. Then we are deploying to dev. You'll notice that we're deploying to dev using a reusable workflow. A reusable workflow is basically a workflow that you're reusing. It runs in the entire job. So my reusable workflow is located here. You path it all the way down. It needs the other job to finish. We're passing in these values. Then we deploy to staging, deploy to prod. Okay, so that all looks good. If we come back up here and look, we can see that we could actually go see, is the deployment to dev actually working? I hope so. It is. Rain and Tupelo. Look at that. I don't remember with prod if I had reset it or not. It is. See, it says rain in Memphis. So there we go. But that's another thing I need to make sure I do is before demo starts, reset websites to original values. Alrighty. So let's see. Oh, hold that thought. All right. So that's the composite action. What we want to see is the reusable workflows. So again, we can do this. We can say github.com/boom. Drill all the way down into the reusable workflow. And then we can explain how the reusable workflow works. We use this workflow call. Boom, 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 boom. And then here's our different jobs. Oh, but now we're also using this interesting thing called an environment. Where do I talk about environments? Right here. So talk about environments. And then we are downloading the build artifacts that were uploaded previously. We're logging into Azure using OIDC, and then we are deploying the website. That's going to take us into back over here into this repository where we can go to settings. We can go to environments. We can see our different environments, dev, staging, and prod. Here's our prod environment where we're also requiring an approval. You can have custom rules. I'm going to add that as an extra. So we'll say if I have time, which I'm not going to have time, but if we have time, we'll talk about custom rules in environments. But I don't see us having time to actually cover that. But we'll talk about environments. We'll talk about secrets and variables. You can see I've got organization secrets, repository secrets, environment secrets. I've also got organization variables, environment variables that I'm using. All right. Okay, great. That's awesome. But, so let's go back to our actions. Let's go back to our little push. And let's approve this deployment. Looks good to me. Ship it. And so that will then kick off the deployment to prod. If you come back over to the code tab, and on the right hand side, if you go down to deployments, you can see the different deployments. So right now we are deploying to prod. We can see that here. We can see the successful and the failed ones for each environment. Come back up here to the actions. We can see it takes about 53 seconds for it to happen. So at this point, we have shown code spaces, we have shown Copilot, we have shown repository rule sets, we have shown environments, we have shown composite actions, we have shown reusable workflows. So the next thing I would want to do is actually add concurrency. So let me get my workspace fired up. Hold on. And I'll make a note that make sure concurrency doesn't exist on the main branch before demo starts. So DevOps Elvis. There we go. Give me just a moment because I'm firing up. There we go. So let's bring this back over here where we can all see it. And here's my code space. All right, so one of the things I have installed, which is handy, one of my extensions is GitHub Actions extension. And I think that's the one that I care about. Yeah, I think that's the one I care about, because what that one should do is, if I come back over to my code, and I'm currently on that feature branch, and I go to the push to main, then it should give me, you can see it, autocomplete. In this case, that's actually Copilot giving me the autocomplete, which is fine. So, and what I want to do is I want to add concurrency. So this is where I would explain what concurrency is. You can actually, there's another value for concurrency. There we go. Control space gives me autocomplete using the plugin. So a little bit of both. So then we explain what concurrency is. So we'll add to push to main. We'll use control space to show that aspect of it. We'll explain how concurrency works. In this case, we're going to take the workflow name and the ref, and that's going to be the unique value. So let's go make this change. And commit this. Sync our changes. Now, of course, we got to go through our process, right? So let's go back over here and let's go to pull requests. And let's create a new pull request. From cleanup and new stuff. Nope, that's not the branch we're on. Feature. We're on the feature branch. There we go. All right, so we'll create a pull request. We'll wait for everything to pass just so that we know it works. Shouldn't take very long. I could bypass it if I wanted to, but if I remember correctly, this should go super fast. Hey, look, somebody's in my chat. Woohoo! Hello, aspiring DevOps guru. I am messing around on Twitch, obviously, but working on a GitHub Actions presentation. But if you got any questions or anything you'd like to discuss around GitHub, I'm happy to see if I can answer them for you. So that worked. So let's go back to our pull request and merge that puppy in. Windows squash merge. And now what we should see on the Actions tab oh, the push domain's not going to run because I didn't modify. That's fine. So it's not going to run because I didn't modify something in the Haiku folder. I modified something in the workflow folder. So we'll just run it manually. And what we're going to notice is when we kick this thing off manually, so there we go. But now we're in that scenario of, hey, another one runs at the same time. This is where concurrency comes in, because concurrency is going to pause that one until this one finishes. And if I started up a third one, what ultimately happens is it kills the one that was currently paused, and it puts the new one in a pause state, which is kind of nice because, again, that's making sure you're not clobbering, having multiple deployments run at the same time, potentially clobbering each other. Which is always helpful. All right. Now, the thing is, with this example, caching doesn't really help. But I can't remember if I promised to talk about caching or not, so let's go look. If we go to Techorama.Netherlands and we go to speakers, these are all the people, if you go to Techorama, that you could see. Let's see. What did I talk about? Custom actions, reusable workflows. That should be required. Oh, I did promise caching. Okay. Dang it. That's fine. Let's go figure out caching. So caching, there's a couple different ways we can do caching. We actually, if we're going to implement it though, the smart place to implement caching is actually going to be in the required, or in the composite action, because that's where it's doing the build and the test. That's the most logical place where you would implement caching. So maybe we don't actually implement caching. Maybe it's more. So, don't suppose you'll venture into the advanced security stuff. Well, let me ask you, what do you want to know about advanced security? I am happy to pivot. Again, I was just working on my presentation, and I did say if anybody showed up, I'd be happy to try to answer questions. So, what are you interested in knowing about advanced security? Is it you just need a general overview? Is there something specific? Because advanced security is made up of a couple of different things, right? You have secret scanning and push protection. You have CodeQL for code scanning. And then, while not necessarily part of Advanced Security, you also have Dependabot, which you actually get for free, which does lets you know if any of the packages that you're using have potential vulnerabilities in them. So I tell you what, you tell me what you're interested in knowing, whether you're wanting a general overview of all of that or you're wanting a specific, topic, and I'm happy to talk about it. I need to move this little chat somewhere where I can see it. Oh, that breaks it, so we'll just keep it right here. Oh, that didn't work good either. I am completely breaking the interface that you can't see, by the way. All right, so you're saying, give me a second here, Mickey is struggling with OBS. So you're saying that, oh no, you're not derailing anything. It's OBS over here on my other monitor, just moving windows every place I don't want them to go. No, you're not derailing me at all. So if you would like a general overview, I will give you my general overview, which is going to be Dependabot, security scanning, and CodeQL. So let's do that. So let me make sure that I don't have anything specific that I need to save. That all looks good. And that all looks good. All right. So let's go to github.com Advanced Security GHAS Workshop. So this is a free, not a free, sorry, it's a public repository that gets used for different advanced security workshops. And one of the things that I like to use it for is for doing demos where I talk about Dependabot, code scanning, and secret scanning. I'll tell you what I am going to do, if you don't mind, real quick, is because we are, switching gears. Not that I don't know if anybody will show up or not, but I'll put that out on Twitter just because I can. Hey, we are switching gears at twitch.tv/MickeyGousset and going to talk about GitHub Advanced Security at the request of a viewer. Feel free to come join. All right, I just want to put that out there. Maybe I'll get, one more person. I appreciate you coming to my stream, by the way. All right, so let me see if I can get myself out of the way just a little more. And let's get started. So, as I mentioned, if you go to github.com/advancedsecurity/GHAS workshop, this is a repository template that you can then use to create a repository from that works great when you're trying to demo advanced security. So I am going to create a new repository. Let me move this over here just for a moment. And the only reason I'm moving it over there is because just to make sure I don't accidentally show something I don't mean to show. And we'll call this GHAS Workshop 4. The only reason I'm calling it GHAS Workshop 4 is because I've called it other stuff in the past. So I'm creating a new repository from that template. And I am going to actually make this internal. So I am running on... So my organization right now is running on GitHub Enterprise Cloud, on an enterprise version of GitHub. Now, most of the stuff I'm going to show you, if you're using public repositories, it's free. But I like to use an internal repository just because it also shows how it would work if you're working with GitHub Enterprise Cloud on an and you're working with internal repositories. Hold on one second. I know this is not good theater, but Trying to get my phone back up and running. Give me 1 second here. That way if people need to call me, they can call me. There we go. Phone's back up. Sorry about that. All right. So we're going to make a repository. So this will take just a moment. And again, like I said, this is a public repository template that anybody can use. So you're welcome to use it to, run through this on your own. You could put it in a public repo and then you can access most of this without even having to have any kind of license. Otherwise, Advanced Security itself, if you're using Enterprise Cloud or Enterprise Server, Advanced Security is an additional license on top of those. Just something good to know. So let's start off with, I always like to start all of these off with Dependabot, and we're already off to the races here because of some organizational level settings that I have. So let's go to the settings of my repository, and you can control the settings for Dependabot, secret scanning, code scanning at the organization level or at the individual repository level. So what you do is, in this case, I'm doing it at the repository level. So I'm going to go to settings and I'm going to go to code security and analysis. Now, here's what we got going on. I have some policies set at my organization level where I'm automatically turning on Dependabot. So what we have going on here is to make Dependabot work. Now, Dependabot is what checks your packages to make sure the stuff you're using from other people doesn't have a vulnerability. Or it will also make sure if you're using GitHub Actions that the action you're using doesn't have a vulnerability. Now, it does that. Oh, excellent. So your company uses Azure DevOps. We also have GitHub Enterprise account. We're exploring things like Copilot and Advanced Security. Excellent. So what I'm showing you is GitHub Advanced Security on GitHub, obviously. We just, I think, general availability today, GitHub Advanced Security on Azure DevOps as well. So the functionality that I'm showing you here, that I'll be showing you with Dependabot, with secret scanning, with code scanning, is also now available on Azure DevOps. It works slightly different, but it is the same, does the exact same thing. So you can check this out either on Azure DevOps or on GitHub. I recommend checking it out on both. I have not, so my background, just so you know, is I have about 13, 14 year background with Azure DevOps. I was around when it came out in 2005 and was just called Team Foundation Server. But I am more focused on GitHub now, not Azure DevOps anymore. So I haven't tried the advanced security for Azure DevOps, but like I said, it's been out in beta and I think it general availability today or yesterday. I want to say I saw that somewhere. We'll do a quick look in a little bit and see if we can find it. Otherwise, if it didn't, I know it's been out there in beta, but I thought I saw something on Twitter or on LinkedIn that said it went general availability. So we're not scanning like your packages though, right? I mean, what we're doing is we're comparing the version of the package you're using to our GitHub advisory database, where we know that, oh, certain versions of packages have this wrong with them. To do that at all, the first thing we have to do is create a dependency graph. And a dependency graph is exactly what it sounds like. It's a graph of all your dependencies. It is a list of all the packages that you're using in this, in your code. So we're hoping to replace an on-prem code scanning tool with advanced security. Well, then let's just jump straight to code scanning. I'll come back to Dependabot and secret scanning in a little bit if code scanning is where your initial view is. I'm curious. You don't have to tell me, but I'm curious what on-prem tool you're potentially using. If you were using, Veracode or Checkmarx or Sonar or any of those. But let's just talk code scanning, right? We'll jump around. Let's talk code scanning. So code scanning is part of advanced security. So you have to have a license for advanced to be able to use code scanning. So what we're going to do is we're going to enable advanced security on this repository. And by enabling advanced security on this repository, we get the ability to access code scanning, and then we get the ability to access secret scanning. Don't overlook this right here, though, because a lot of times you have security people that want to be able to view the alerts. They want to be able to see the alerts. However, you don't necessarily want to give security people, a lot of access to your repository. And for certain alerts, like secret scanning alerts, you have to be an admin on the repository to see those alerts. Unless you're the developer that checked in that secret, in which case you can see your alert, but you can't see any of the other ones. What this does is allows you to define a team or multiple teams that says these people have read access to repositories with GitHub Advanced Security turned on, and they can see and manage all the alerts. So it's an easy way to give your security team access to all your repositories without having to necessarily give them extra rights that you don't want to give them. But we care about code scanning. Now, how does code scanning work? Well, we have a couple of different ways to set up code scanning. Now, I'm going to show you the more advanced way first, and then we'll come back and talk about the default way. The difference being the advanced way, you're using Fortify. Yeah. Yes. So I have worked with customers before, helping them compare advanced security to Fortify. I have some customers that use advanced security and Fortify. I have some customers that use multiple scanning tools. I have some customers that went to code scanning, GitHub code scanning from Fortify. So it's definitely what you want to do in that case is you want to do your due diligence, right? You want to make sure that you compare the two tools and make sure you're getting the results you expect to get, and that CodeQL is doing what it needs to do for you. I will say in every case I've been involved in, it has worked as well or better than Fortify. Is based off, and again, that's Mickey's pure unscientific analysis, but just working with customers. My day job, by the way, on the GitHub Fast Track team is I go out to customers for 1 to 2 weeks at a time, and I help them get more DevOpsy, whatever that might mean, but with a GitHub focus. A lot of times it's helping them get enabled with advanced security, or helping them get enabled with actions, or just even getting their GitHub set up and running. So there's 2 ways to set up code scanning. There used to only be one, and that was this advanced way, which was configuring a GitHub Actions workflow file and then having that run your scan. There's now a default way. And the difference between these two is with the default way, it only runs on, I think, a pull request and a push, but it handles it all behind the scenes. You don't see a GitHub Actions file. The catch is that means that you can only use hosted runners. So you can't use self-hosted runners if you're, which for some companies, they have to use self-hosted runners, in which case you have to do it from the advanced perspective. So we're going to do it from the advanced perspective first, and then we'll come back and do it with the default, just to show you the difference. Now, let's do a couple of things. So when you go to create this code scanning, when you're using the advanced way, when you go to create the code scanning, it gives you this GitHub Actions workflow file. So we're going to call this, we'll give it a display name. We'll call it Mickey CodeQL. And I'm going to change this to also be Mickey CodeQL, just so I can easily find the file. Now, depending on how much you know about GitHub Actions, which is GitHub's workflow automation system, we've got all the workflows end up off of the root in .github/workflows, and they're YAML files. So in this case, these are the triggers that it gives you by default. A GitHub Action workflow file will trigger off of any event inside of GitHub. In this case, we're triggering off of a push to main, a pull request to main, or a cron schedule. Fun fact, if you don't really know how to do cron stuff, or what that means, if you hover over it, it will actually tell you what the schedule is, which is kind of nice. But you know what? I don't want any of those right now. What I want to do is just be able to run this thing manually. So I'm going to just remove all of those. I could have commented them out. And instead, I'm going to add the event workflow_dispatch, which allows you to run your actions manually. This workflow has one job called analyze. There's the display name for analyze. When you execute a runner, or when you execute a workflow, it has to run on a runner. So this is basically saying it's either going to run on Ubuntu or it's going to run on Mac OS, depending on the languages that I'm using. This is where, if you were using self-hosted runners, you could specify your self-hosted runners as well. And then we have to give the workflow a couple of extra permissions to be able to make the scanning work correctly. Now, what we see here is when we told it to create this file, it looked at our code and it said, I think you have all these languages in your code. Now, you may or may not have all these languages in your code, and you can also remove them. You can see we support right now C++, C#, Go, Java, JavaScript, Python, Ruby, and Swift. Yes, this is very similar to Azure pipelines, to YAML, but it is not the same YAML syntax. So that's the other thing. We do have a tool that if you ever want to move your Azure pipelines to GitHub Actions, we have a tool that's free called GitHub Actions Importer, which will actually can take your Azure pipelines and convert them to GitHub Actions YAML, and it works with classic pipelines as well as YAML pipelines. So obviously we check out our code. Then we have this step, which initializes CodeQL. So we're calling an action or a task called a init, which basically installs all the stuff we need on the runner to make CodeQL work. Now, I say CodeQL. I should be saying code scanning. CodeQL is the language that all of our queries are written in, and it's the language that's used to do the code scanning. You can actually write your own custom queries if you want to be able to scan for certain things if you really want to dive into it. I've heard CodeQL is a little bit of a difficult language. I have not tried to build my own custom queries yet. And basically because we define the matrix, we're gonna spawn 4 jobs at the same time. One dealing with Go, one dealing with Java, one dealing with JavaScript, one dealing with Python, and they're all going to execute these same steps. This is going to initialize CodeQL. Now, by default, when you run code scanning, it executes our default set of queries. We also have an extended set of queries called security extended that have extra security queries as well as some quality queries in it. So we're going to go ahead and run the security extended. Actually, we're not going to do that right now because it'll run a little bit faster without that. Then for code that needs to build, like Java, like C++, we've got to build the code. So we have a step here called auto build, which does exactly what it sounds like. It tries to build the code. If auto build completes, great. If auto build fails, then you have to add in the appropriate steps in your YAML file to build the code. I would say I'm probably about 50-50 with having auto build work, depending on the complexity of the code base. And then finally, the analyze action, the CodeQL analyze action is what actually does the analysis. So let's commit these changes, and like any good developer, we'll commit them directly to the main branch. Oh, yes, it is. Don't be difficult. It's there. So let's run this, right? So if I come back over to Actions, I can select Mickey's CodeQL, and because I used the workflow_dispatch event, I can run this workflow. And Let's see. You can see it spawned 4 jobs all at once: Go, Java, JavaScript, and Python. Some of these are going to run faster than the others. Probably going to take a couple of minutes to run. Now, how fast this thing runs purely depends on the code base, right? If you've got a huge code base with millions of lines of code or that's very extensive, it's going to take a little bit longer to run. For smaller code bases, it won't take quite as long to run. And for each job, like you can see for the JavaScript job, we're check out the code, we're initializing the repository. We're doing the same thing across all of these. Hey, wow, I got a second person in here. Hi. So we're talking advanced security because Aspiring DevOps Guru showed up and nobody else was here and he wanted to talk advanced security. Well, nope, I'm good. I don't need any custom graphics right now, but I appreciate it. Thank you. So you can see a bunch of junk going on, but here's the skip auto build, which didn't do anything. And then we've got code analysis that's running. So this takes a couple of minutes to run, right? Which is one of the reasons why you don't want to run code scanning, like say on every push, because by running code scanning on every push, it's going to really slow down things potentially for your developers. So usually where you run it is on a pull request or potentially on your push to main. Honestly, I don't really have I can't remember what my Discord is. I think it's either Mickey Gousset or Mickey.Gousset. So feel free to hit me up there if you'd like to. But you can see the JavaScript finished and everything finished and completed successfully. So where do you go to see the results of the code scanning? Well, that shows up here under the security tab. And if we go under the security tab, then you'll see we have a Dependabot, which has found 90 potential problems. But here's the code scanning, which so far has found 4 potential problems. Can you tell the scan tool to filter out certain file types or directories? You don't tell the scan tool to filter them out so much as in the where is it? In the workflow itself, you could be a little more selective in, say, the checkout action and only potentially check out certain parts of the repository, or you could only trigger if certain parts of the repository are modified. But I don't have a way in the actions here to be able to tell it, don't scan these certain file types. At least that I know of at this point. I'll double check that after a bit, but I don't think I have that capability. Now, if we look at the alerts that were generated, that's a good question, though. That is a great question. I'm going to take that question, Aspiring DevOps Guru, and I am going to save that question and go research it to make sure that I know the answer, the exact answer, but I don't think you can at this point. So here we've got 4 alerts that were found by our scanning tool, by CodeQL. Now, the thing about having advanced security installed is, let's say you're using CodeQL, but you're also using Fortify. You can take the output from Fortify, because Fortify can put its output in a serif file, serif format. You can load that serif format file up into this repository, and then you can view the alerts from both CodeQL and Fortify all in one spot. So that can be very handy, because your developers don't have to context switch to go to look at Fortify and see what Fortify found. They can see all that information directly here in the repository. Now, if we look at these alerts that were created for us, for example, this one, we can see what it does is It's telling us this is a clear text logging of sensitive information. Okay, that's cool. It gives us where it found the problem. It shows us details. It gives us information on the problem. Gives us examples of how to potentially fix the problem. Gives us references to all the CWEs where this is a problem. You can even create, if you want to, you can create an issue and tie that issue back to this alert. So you could use that issue to track being able to fix this alert. Now, if you fix the code problem and rerun the scan, if the code problem is fixed, the alert automatically closes. Now, sometimes, so one of the things you have to decide when you're looking at all these alerts, you can see we got a couple of more, is what is your level of comfort, right? Because when you start running these code scanning tools, you're not going to, ideally, yes, we want to fix all of them. Is that practical? Not so much. So maybe it's we have to fix all the critical ones before we can deploy, or we have to fix all the critical and the high before we can deploy. So that's something to consider. Now, of course, you can also sort by all these different things, but it could be you've also got one of these CodeQL that you consider a false positive. So you can mark it as a false positive. Or maybe it's something that you're doing from a testing perspective, so it doesn't matter that this is being flagged. Or you're just not going to fix it. We don't have time, we don't have budget, whatever, we're not going to fix it. So you can actually close these alerts out by selecting a reason and giving maybe a dismissal comment. And what you'll see is if I come back to my security tab and I go to code scanning, I now have 5 open and I have 1 closed. So ideally, you're going to run code scanning, again, not on every push, but but more likely on the pull requests. So in your world, it's all critical and high, unless it's something PCI related. Then it's everything. Yes. Yes. Awesome. So you've got a plan there. So that's good. So that's code scanning. No, so that's getting us started with code scanning. So let's go back to settings though, and let's go to code security and analysis. And let's look at a couple of other things. All right. So you'll notice here it says other tools. So you could create a GitHub Actions workflow to do a Fortify scan if you wanted to. Or let's say you're doing your Fortify scan, and so I could click configure, and this will create another GitHub Actions workflow file that downloads the Fortify scan client, and tries to set up Fortify for you to use. Or let's say you're doing your Fortify scans in Azure pipelines. You could take the results of those Fortify scans and use the API to push those results back up into this particular repository if you wanted to. So I have seen customers that, they are willing to run multiple tools because they just want to make sure that they are as protected as they possibly can. One of the things you can do with code scanning is if you run this code scanning as, say, whenever you create a PR, then you can actually have a protection rule which says if that code scanning finds, critical alerts or higher alerts, we're going to block that pull request until those are fixed and a clear scan runs. So you can use that to control, making sure that the code meets those minimum standards of high or more before it can make it from your feature branch to your main branch. Now that was code scanning. I showed you the advanced way of doing it. Let me show you what the default way looks like. So the default way pops open this default configuration. it says it's thinking right now it's only going to use Go, JavaScript, and Python. So notice it's 3 of the 4 languages. Java, which my other one was trying to use, is not mentioned here. And that's because this thing's going to try to do an auto build. Compiled languages don't work as great right now with the default configuration. So the default configuration can work great if you're using interpreted languages and you don't have to access anything on-prem. All right, so can you also block a deploy workflow from going to prod in that event? So that setting is not going to block the workflow. So you could, yes. So we don't have an action right now that you would add a step, an action into your workflow that would want to check to see if there are outstanding alerts. Right now, we don't have an action that does that. I know the community has built some actions that do that, as well as you could build your own, right? You could make an API call to determine if there's open alerts. So yes, I could block that. Oh, even better. And again, I don't know how much you know about, or don't know about GitHub Actions, but when you're doing deployments with GitHub Actions, normally what you define is what's called an environment. And then you have a job that targets an environment. Like I've defined a production environment here. And in my production environment, I'm requiring these people approve it before it deploys. But you can also build your own custom rules. So you could build a custom rule here that goes and checks to see if there are any, critical or high alerts from code scanning. And if there are, that rule will block the deployment from running until those get resolved. So the answer is yes, you can, but you're probably going to have to use a little elbow grease to build it. So if we come back over here to the default setup, I just want to show you that I can tell it to do the Java, but it may or may not work. I can specify the default to the extended queries, and I can specify that it run and by default it's going to run on push and pull requests as well as on a weekly schedule. And it takes a few minutes to set that up, and then it runs at least once. Now remember, the default way is using hosted runners. So if you use hosted runners, it's not exactly like Azure pipelines. It's a little bit different. Well, with hosted runners, you can use as many hosted runners as you want because you get charged minutes, right? So, and with your enterprise plan, you get 50,000 minutes, and then you get charged, so small, I can't remember what the increment is per minute that you use. With self-hosted runners, you can have as many runners as you want to. You can run as many, and you can run them in parallel. It's not like Azure pipelines, I think, where you used to have to buy a certain amount of pipelines to be able to use self-hosted runners. But you have to maintain them. And that's the whole thing with self-hosted runners. It can be a little bit of a pain to maintain those. But that's the basics of code scanning, right? This is going to take a little bit of time to set up. What you're going to notice here, if we go back to the Actions tab, is that we now have a CodeQL workflow. This wasn't here before. This is the default workflow that was set up for us, that it's going to then run those jobs and upload the results. I personally prefer doing my my code scanning using the more advanced way because I have more control. Plus, it works better with compiled languages because if the auto build fails, I have the capability to add the steps in to make the build work. So that is the basics of code scanning. Now that's only part of advanced security, but obviously it's an important part. So you got any questions around code scanning, or would you like me to talk a little bit about how secret scanning works, which is the other paid part of advanced security? I'm going to assume you care about secret scanning, so I'm going to show it to you. And but I'll watch the chat. If you decide you're not interested in secret scanning, or you have specific code scanning questions, I'm happy to answer those as well. So secret scanning good question. Can you do any reporting off of this information? So if you have, so we don't have any reporting built into GitHub. However, if you use Splunk, we have a bunch of free dashboards for Splunk. So what you can do is configure GitHub. I think it does it via webhooks to, as CodeQL information is discovered, or Dependabot information is discovered, or secret scanning information is discovered, it webhooks that information over to Splunk. And then we have dashboards that we've built that can slice and dice that information for you. If you don't use Splunk, or you use some other reporting tool, then you can use the same method, right? You could still take the webhooks, send the data to whatever tool you're wanting to send it to, and then suck the data out of the payload so that you can slice and dice it appropriately. I want to say, give me a second here. I want to say that I actually have a Splunk dashboard I could show you. I want to say that. Whether I'm going to say that is a whole nother story. Let's see. Give me 1 second. Ooh, I might actually have a Splunk dashboard to show you. And then we'll talk secret scanning. Yes, it's me. Sorry, I'm doing the two-factor authentication dance. Is this it? All right, 1 second. I promise we'll talk secret scanning. I am trying to see. There we go. So, but if you do use Splunk, then we do have a GitHub app for Splunk, where then you can pull the data in and you can see a breakdown of Dependabot, secret scanning and code scanning, open alerts. You can break this down by, specifically, say, code scanning alerts if you want to. And then you can drill into the code scanning alerts and see, mean time to resolve. And again, since it's Splunk, you can also go build your own custom dashboards if you want to. So lots of good stuff there. So when people want reporting on advanced security and Dependabot, I usually point them to that Splunk dashboard. Now let's enable secret scanning. Now, here's the thing you need to know about secret scanning. Secret scanning, by default, what we're doing is we're scanning for partner secrets. So we're scanning for things like GitHub personal access tokens, Azure DevOps personal access token, Azure credentials. We've got about a lot of partners that we work with to be able to scan for their secrets. what would really be great is to give my security friends a self-serve report generator. This way they don't have to harass me for audit reports. I can appreciate that. Unfortunately, that's probably something you would end up having to build. I suspect if you do a little digging in the community, you're going to find some people that have built some actions or even some entire workflows that may do something to help get you started down that path. So as I mentioned, by default, secret scanning, when you turn it on, by the way, it scans your entire repository and your repo history. And it is scanning for partner secrets. You can also define your own custom secrets, right? You can define, so you can create a regex expression that looks for password equal something if you wanted to, or whatever it might be. So you can define your own patterns that you scan for. But out of the box, we're going to scan for all of these partner secrets. And we're going to scan your repository and your repository history as soon as you turn on secret scanning. And then every time you do a push, we're going to scan as well. And we also have what's called push protection, which basically stops you from being able to push a secret from your laptop up into GitHub. I'll show you that in a moment. First thing I want to show you is if we come back up to the security tab, you can see we found 8 secrets. Now, secret scanning, always running. Unlike CodeQL, you don't have to run it as part of a workflow. It's always running. And every time you do a push, it's going to check those files to make sure you didn't include something. Now you can see I have found these 8 secrets. If I click into one, it tells me the location of the secret, shows me even what the secret is. So what do you do if we find a secret? Well, the first thing you do is you rotate that secret. All right, that secret's in your repository now. Now, you could rewrite your repository history using a couple of different tools or using some Git commands. I don't recommend that because that messes up the chain of custody, so to speak, right? And especially if you've got a lot of compliance things that you have to deal with. So instead, you rotate the secret. Now, secret alerts by themselves are never going to go away. You have to close them. So you close them as either revoked, or maybe this is an okay secret to be in your repository because it is used for testing. Or it's a false positive. You don't think it's a real secret. So you can close, or you're just not going to fix it. So you can close out your alerts that way if you want to. But what and around secret scanning, it shows you, if we go into another one of these, again, it shows you where in the code it found that problem and gives you suggestions on what to do about it. But what I really like about secret scanning is, let me go to settings, code security and analysis. What I really like about secret scanning, push protection. Because now that I have enabled push protection, when I make a code change and I push that code change up, it's going to check to see if I have any secrets in that code change, partner secrets. Now, it doesn't use all the partner secrets. It uses most of them, but we're only using the ones that we feel really, really, really confident are not going to give you a false positive. So what we're going to do here is I'm going to show you how this works. So I've enabled push protection at this point. And the beauty of push protection is that it will work whether I'm editing in the web browser or if I'm editing on my local machine and trying to push up. So let's have some fun. Oh, give me 1 second here. Let me do this. I'm going to go find a personal access token for us to use. And then I'm going to quickly disable that personal access token. I'm going to create one that can't really do anything. Don't get any ideas. Be nice to me, I'll be nice to you. Fair enough? So I'm going to generate a new token. Doing the dance. And this is testing GHAS. And I'm just going to generate the token. Now, let me put this somewhere where I won't lose it. Now, the nice thing is, if you're in a public repo and you check in, say, like a GitHub token, it automatically revokes it for you. And if you're in a public repo and you check in a partner token, then we actually tell the partner that we found the token, and the partner decides whether to publicly revoke it. When you're working with GitHub Enterprise Cloud or a server, and you're working with an internal or private repo, then it's not going to revoke it by default. So what I'm going to do, though, is I'm going to go ahead and kill this token. It's still a valid token, but I'm just removing it so people can't futz with me when they watch this recording. And what we're going to do is we're going to come back out to our code. Now, I'm safe here. Thank you. I do want to point out that if you have files that you want to be ignored by secret scanning, in the .github folder, you can add a secret scanning file. And that secret scanning file, you can specify the paths where it will ignore checking for secrets. So in this case, it's going to ignore the README and it's going to ignore the exercises. So let's go into front end. And let's just open this up. And let's make a change. And I'm just going to cut and paste a GitHub personal access token. Now we've enabled secret scanning, we've enabled push protection. So in theory, if I try to commit these changes, I get this, secrets detected. If I was doing this from the command line, then it would pop up on the command line, secrets detected. So it found a secret. And it says, do you really want to commit this change? Because maybe I think it's a false positive. Now, if I was doing this at the command line or from VS Code or something, then it would give me a URL that I would enter. And I would go to that URL and it would give me this same kind of message. And I could say, you know what? Yeah, maybe I cancel out, so I'm not going to do it. Or maybe I think it's a false positive. So I'm just going to say, I'm using this in tests, which is what I'm doing. And I'm going to allow the commit to happen. And now I have 3 hours, I think it's 3 hours, to be able to actually do this commit. So we'll try it again. I'm going to commit to the main branch. And this time the commit went through. However, it went through. It did create an alert. And because you overrode the push protection, the repository admins, the security team, if you've set up the security team, and organizational owners will all get an email saying that Mickey Gousset just overrode push protection to push in this commit. And it's caught in the audit log as well. So if people are monitoring their audit logs, you would catch that event too. So you can get past it because it's possible that it could be a false positive or something else, or like, it's used in tests, so it doesn't matter. But people are going to know you did it. But I really like secret scanning. I like that you can define your own custom secrets. To scan for, and you can define those at the enterprise level, the organization level, or the repository level. And it works really well. Now, if you're using public GitHub, if you're using public repositories, secret scanning is turned on by default. You can't even turn it off for public repositories. All right, I got one more thing I'd like to show you, and then I'm old and I'm gonna have to go to bed. But the other thing I wanted to show you briefly was Dependabot. So in order to make Dependabot work, the first thing you have to make sure is turned on is Dependency Graph. And Dependency Graph shows you all the dependencies that your code uses. Obviously, this is a demo repo. It uses lots of, bad packages. Now, once you have Dependency Graph turned on, if we go back to Code Security and Analysis, then you can turn on Dependabot Alerts, which mine was already turned on. And what that's going to do is it's going to take the versions of the packages that it finds that you're using, going to compare them against our database of problems, and it's going to throw alerts. And we can see here, I've got 90 Dependabot alerts, 90 problems that it's found in the packages. And if I go into one of these, such as Prototype Pollution and Minimist, you can see it shows me that if I do the upgrade that it's suggesting I do, which is move to at least version 1.2.6, I'm actually going to fix a couple of different Dependabot alerts. It shows me the version I need to upgrade to. I'm calculating my score at 9.8 out of 10, so it's critical. And these are all of the values that I used to determine that 9.8 score. I give you a link to the CVE. I give you a link to the GitHub Advisory Database. And in the GitHub Advisory Database, that's where we've got even more information about, why this is a problem. All the references. Now, if you fix this, if you upgrade, modify your package JSON or whatever to make sure you upgrade to the minimum version, then Dependabot will scan again, and it will automatically close the alert. Dependabot's always running, just like secret scanning. You don't have to run it as part of a workflow. It's just always running. You can also manually ask Dependabot to try to create a pull request for you to make this update. Now, sometimes it can, sometimes it can't. If it thinks it can update your manifest without breaking anything, then it's going to do that. If it doesn't think it can update it, then it's not going to do it. But it'll try to create a pull request for you to fix this problem. It'll create a branch, update the manifest to the minimum version, and create a pull request. Now that's handy, but the big problem people have when dealing with this type of package scanning is developers don't always go and look at it, right? They don't always go and look at the alerts. Sometimes you want to throw it in their face a little bit that there's something out there that they need to look at. So you can enable, now this, this is in beta. I've never used that, so we're not even going to go down that path at this point. I'll have to say that for some other time. But Dependabot security updates allows you to have Dependabot automatically try to create you pull requests. So you can see it. That's the one that this was opened by Dependabot. So what it will do is it will try to automatically create pull requests that you can use to try to upgrade, right? And you'll notice that if I merge this pull request, it's going to resolve 2 alerts. I can see the files that are changing, package lock, the package JSON. I can see information about what I'm upgrading to. In this case, I've got code scanning that's going to try to run because we have it set to run on a pull request. But the goal is put this in front of yourself, put this in front of you. Dependabot. Dependabot look at NuGet package references as well, or just limit. No, it's not just limited to NPM. let's see, GitHub Dependabot docs. Let's go see if we can easily find what Dependabot works with. Dependabot. No, it's going to work with more than NPM. I know it's going to work with NuGet because I got an example that works with NuGet. It works with several different package management systems. I just can't find where it tells me exactly where it works. And the other thing you can do with Dependabot, so it creates these, right? You can, and the idea being, if you could have it auto create these pull requests, which then try to throw in front of the developer, hey, you need to go update this. Some people like that, some people don't, because some people don't like their repository getting cluttered with automated pull requests. The other thing it can do, and this I actually kind of like, is if we go to settings and we go to code security analysis, you can enable version updates. Now, this requires you to have a file, a dependabot.yaml file that specifies the different package ecosystems that you might be using, like NPM, like NuGet. I can't remember if we support Python right now or not. But what this does is it looks, say you're using version 2 of a package, and version 2.1 comes out. Let's face it, most developers don't go looking for a new version of a package unless there's a security problem or they're, for some reason, checking to see if there's new functionality they might need. What this does, the version updates, is it checks to see if there's a new version of the package out there. In this case, it would check weekly. And if you're using version 2 of that package, if it finds version 2.1 of that package, it will create a pull request for you to try to, and it will modify your manifest to be able to move you to that version, with the goal being it lets you know that version's out there. Now, hopefully your developers don't just go accept that pull request that's got to go through testing or whatever, but it's at least letting your developers know that there's something out there, a newer version of the package that they might want to check out. And finally, if you own Advanced Security, then there's an action you can have run in a workflow called the dependency action. And what that will do is check the code that's in your PR to see if you have added a package that's a bad package. And if so, it will block the pull request. All right, so mine is going a million different directions. Does it look at your target framework? No. It does not. Dependabot does not look at your target framework. It's purely looking at your manifest files and to determine the packages that you are relying on in your, to write your code. It's a great question, though. And there you go. That is Dependabot, and then also Advanced Security with code scanning and secret scanning. So, with that, any questions? Oh, I love doing this stuff. I appreciate you coming to my stream. Like I said, I'm doing this. I'm checking out this Twitch stuff. I mostly do stuff on YouTube, right? So if you're interested in actions and some of this other stuff, if you go to youtube.com/Mickey Gousset, I'll plug myself. Why not? So if you go to youtube.com/MickeyGousset, I even got over 1,000. Oh, wow, it's gone up. I was so excited. I hit 1,000 followers like last February, and now it's almost at 1,700. And I don't post that often, and I really should. So stuff out there. Oh, if you want to see some of my animals, you can see my shorts too. So anyway, I love doing this stuff. Is there any way someone can donate to you in your work? Right now, I really don't have a way. I'm not that far along in my journey to where I'm trying to earn money from it yet. Though I appreciate you asking and offering. I just love it. Keep coming back and asking me questions. Right? Hit me up on Twitter. So Twitter's a little bit different. Or Twitter has an underscore in it, so it's Mickey_Gousset. You may or may not use Twitter, but you can hit me up on Twitter. That's one good way to potentially get in touch with me. Or I'll be completely honest with you. If you want to get in touch with me, you can also just, let me pop this up on the screen too, because it's not like it's hidden from the world, right? But if you also want to get in touch with me, you can also send me an email, right? MickeyGousset@github.com. So Twitter's a good way to hit me up. Email's a good way to hit me up. However, I don't check my email necessarily all the time. So you might get a slightly faster response from Twitter, maybe not. But if you've got questions as you continue down this journey, right, as you continue going through GitHub Actions and working your way, or not GitHub Actions, but Advanced Security, if you got questions, hit me up. If I can give you a quick answer, I most definitely will. Or maybe you'll ask me something good and I can either make a YouTube video out of it, or I can come back here on Twitch. I'm trying out Twitch again. I tried it for a while, found it confusing. I'm trying it again because honestly, if nothing else, it keeps me focused. But I also like the real-time interaction with people. All right. Any other questions I can answer for you, aspiring dev or aspiring DevOps guru? All right. Well, then I am probably going to call it an evening. You have a good night as well. And probably do this again tomorrow. All right. I'm signing off, everybody. See ya.